Okay, how are you all guys doing? How is everyone? How is everything? Welcome to Yebo Tutor Livestream Help. I'm so excited to be ready to assist and be ready for everyone and each of you. It's been quite a great holiday. I hope you also enjoyed your holidays and I hope it was so fantastic as well at home. My name is Vianney. If you are still new, if you don't know, my name is Vianney. I'm the one who is taking you guys for mathematics. So now we are starting with our preparations for grade 12 preliminary exams, which is trial exams. So I've been getting like many questions and also on our WhatsApp group. So if you are new, don't forget to enter or join our WhatsApp group and also subscribe on the channel and also follow us on our Facebook account. We also post our videos which we live stream here, and it will be amazing that we can interact because the idea behind everything is for us to have a nice interaction session so that we can interact together. If you have any questions anytime, any minute, anywhere, you can just WhatsApp us on the WhatsApp group Yebo Tutor. The link also is also in the description of this live stream. I hope you'll be enjoying, and don't hesitate to text something on the comment section if you want me to repeat something or to dwell more on that specific section. So let's get ready and let's look at the trial exam. So we're gonna start looking at paper two because paper two is a bit tricky and a bit hard, but it's lovely as well because it's only four topics on paper two. So we have statistics, we have trigonometry, we have analytical geometry, and the boss, which is Euclidean geometry. So we always know that Euclidean geometry is like 50 marks, trigonometry is like 40 marks, analytical geometry is also 40 marks, then statistics is 20 marks. So you just have to know your story, and if you see trigonometry, analytical geometry, statistics, you just have to get all total marks because it's not hard. Then in Euclidean geometry, let's try to have the reasoning behind those shapes which will be given, the circle theorems, knowing those theorems. But don't worry, we'll be there for you and we'll assist you through. We'll be having like live sessions each and every session with you. On Mondays, I'll be doing maths with you. Okay, great. Let's get down to the business of the day. So you can see now we are going to be doing or to be looking at the prelim 2021. So we're gonna go 2021 and we're gonna go down as well. Okay, so we are doing 2021 National Senior Certificate your trial exam. So on the trial exam, we'll be looking at maths paper 2. As you can see, it's September 2021, and let's go down. This is statistics. As you can see, it's like plus or minus 20 marks, and it's not that hard. It's quite easy. And you can see this is analytical geometry, as I was saying. It's 20 plus 19, so it's like 39 marks. Then now to the core of what we are doing today. We are doing um trigonometry. So we're gonna look at our questions. Don't hesitate to ask if you have any questions so that we can help each other and have solutions and have the depth understanding which we are looking for. Okay, great. So on the problem which we have on the screen right now, point T, -1 is to -2 is given in the diagram below. A is a point on the x-axis such that reflects a angle O. T is equal to alpha. Determine without using a calculator the value of the following. Underline that part. The basic, most important part is to understand what do that the question wants. So for this instance, they say that without using a calculator. So don't use your calculator because if you use your calculator, you're gonna get complete zero. Now let's get down to it. Great. So now on our 5.1.1, on our 5.1.1. Okay, great. So as you can see on 5.5, 1.1, we are given that nice Cartesian plane, which has, sorry about that. Okay, great. It's like this, which has a point. I'm gonna draw it first. So here we have it. Then it has a point T, which is -1 is to -2. And also we have point A, which is the x-intercept, which means this is point x comma 0 because it's the x-intercept, so that automatically means that the y value will be 0. Then we are given this point, which is -1 is to -2, and we are also having this reflex angle, which is alpha. So what is important is to understand few things, or is to understand this effect that if you are given a point, maybe point A, which is 1 is to 2, when you are drawing this on the point, let me just use x since we are given A here. When you are given x is got 1 is to 2, we know that this first value is the x value and this is the y, because you are given in the coordinate system. So your mind must be able to think fast. So for instance, you'll be able to plot this point. Point 1 is somewhere here, then where is 2 is somewhere here. So where they intersect, that's the point. So that's the same thing which we are having here. So in other words, this -1 is -2 is the same as, like, let's just draw this construction here. Then we form our 90-degree here. Let's draw it here. Then we form our 90 degrees here. You can actually see that, okay, -1 is on the x. So in other words, this is -1. So from here to here, it's -1. Then from here to here, it's -2. Because this is x, this is your y. So now we must be able to find our r. So in order for us to answer this section without using our calculator, the first step which we are supposed to apply is to make sure that the triangle, the right angle triangle which we have, is comprised of all the sides. The opposite side has a value. The adjacent side also has a value, as well as our hypotenuse side. So now we are looking at this diagram and we are saying that no, man, we don't have anything on the hypotenuse side. So let's calculate the hypotenuse side. We use the Pythagoras theorem. What does the Pythagoras theorem say? R squared is equal to x squared plus y squared. So what was our x squared? It's -1 squared, plus what is our y squared? Our y squared is -2 squared. That's our r squared. Then our r squared will also be equal to 1 squared is 1 plus 2 squared is equal to 4. So definitely you can actually see that the r will be equal to √5. Why? Because we square both sides. Then after that, since it's r squared and we only want r, we remove our square bracket by we remove that squared by squaring both sides. Then our r now is equal to -√5. There is actually a mark for having this value of r. There is one mark for just showing that value of r, because sometimes we think it's not important, but this is the crucial and the important part, that you show that you have calculated this value of r. Now let's look at our problem number 1, 5.1.1. We are done with our diagram. Determine without using a calculator the value of the following. Tan alpha. So what do we know about tan alpha? So we were taught in grade 8 that tan is opposite over adjacent. So now you know that your triangle is filled up, your right angle triangle is filled up, and every side is given. We have calculated all values. So we know that tan is opposite over adjacent. So in this case, it's going to be -2 over -1. So our tan alpha will be just -2 over -1, which is the same as 2. Just as simple as that. Why? Because we know that tan theta, or tan of an angle, is equal to opposite over adjacent side. Now 5.1.2, determine cos of alpha. It's now 2 marks now. What is cos? We know that cos of an angle is equal to the adjacent side over the hypotenuse side. So given that a diagram which we had in our test paper, it was not giving us the value of the hypotenuse. So that's why we calculated it. So now they are asking us about cos alpha, and we know that cos alpha is the same as adjacent over hypotenuse. So what is our adjacent side? Our adjacent side is -1, and our hypotenuse is √5. As simple as that. Then we have our 2 marks. For 1 mark, 1 mark. Then we have our 2 marks. Great. Let's move forward. Now 5.1.3. So now we have cos of alpha plus 45 degrees. So knowing about, or seeing this, they're saying in simplest form. So the things which you can do here is to apply what we call the compound angle. So let's expand this and apply the concept of compound angles, because we know that referencing you. So because we know that cos of A plus B is a compound angle, which is the same as cos sine. But since it's positive here, it's gonna be negative. So this is the concept which we are using of our compound angle. So what are we gonna do here and solve this? So we're gonna write our answer here. So we're gonna say equal to cos of alpha multiplied by cos of 45 degrees minus sine of alpha times sine of 45 degrees. What is cos alpha? That is something we should have calculated in 5.1.2. It's negative 1 over root 5. And what do we know about cos 45? We have our special triangles. Bear in mind that they say that without using a calculator. So in other words, you must also know our special triangle. So in this case, we are dealing with 45. So you must draw your special triangle for the angle 45 degrees. So it's going to be in this order. So we have our 90 here. Then now we draw our triangle. So we have 45 and 45. Then it's going to be 1, 1, and root of 2. So always know the special triangles by head so that you can be able to apply them with an immediate effect. So now we know this small fact, we know this special triangle. So now what is cos of 45? Cos of 45 is the same as 1 over root 2. Where are you getting this? You are getting this from your special triangle. You didn't use your calculator. So bear in mind that if you use your calculator, you're going to have root 2 over 2. So the examiner or the person who's going to mark your script is going to know that this person was able to use your calculator. So please follow the instruction. When you're not allowed to use your calculator, please don't use your calculator so that you can get the correct answer and get full marks. So cos 45 is 1 over root 2 minus what is sine alpha? Sine alpha is opposite over hypotenuse. So opposite is negative 2 over root 5. Let's go. It's negative 2 over root 5. What is sine 45? It's also 1 over root 2. Then after this, let's go. So it's going to be negative 1 over root 5 times 2 is the same as if you arrive from this step, just to make this easy for you, so you get marks for being able to write this in this form. So you get your marks for just writing this in this form. You also get your mark for writing in this form. So 1, 1, it's a 4-mark question. Now you already have 2 marks. Now let's go and proceed now. Root 5 times root 2 is the same as root 5 times root 2. So we must be able to use our calculator in that instance. Or using our calculator. Now, why are we using our calculator? We are using our calculator because we have already simplified everything and used the right values. Because if you're going to use your calculator from step number 1, you're going to get a wrong answer. But now you have the correct value. So please don't do that simple mistake. Make sure that you use your calculator only if you don't have our correct values. Great. Now we have root 5 times root 2. Then we also have root 5 times root 2. So we can actually see it's root 5 times root of 2. Then we have negative 1 minus root 5 times root 2. Then we have on top negative 2. So let's combine the denominator. So it's going to be root 5 times root 2. Then it's going to be negative 1 plus 2. So this is the same as 1 over. Then root 5 minus times root 2 is the same as root 10. Okay, so that will be our final answer. So you now get your 4 marks just like that. Okay, so without using a calculator, from this step you can apply your calculator. Why? Because you've already outlined the original values which are wanted. For instance, the values of cos 45, the values of cos alpha, the values of sine 45 as well. So from this step you can use your calculator, but from above 3 steps you can't use your calculator. You will be penalized full and you won't be awarded full marks. So please be careful of those problems. You can see it's a 4-mark question, which means it needed you to have critical thinking. Now let's move forward now to the next question, which is 5.3.1. Let's move on to 5.3.1. So on 5.3.1, so we are given that 5.2 first. 5.2. So we are given 2 sine of negative 20 times sine of 160 degrees minus cos of 40 degrees. Okay, so let's solve this problem. Let's solve this problem together and see how nice it's gonna be. Great, let's go now. So now, bear in mind that when you're solving trigonometry, always have what we call the reduction formula in position so that you can solve anything, anytime. Okay, great. So now we know that sine of a negative angle is it's still negative, so we're going to have negative 2 sine of 20 degrees. Then we multiply by sine of 160 degrees. So we can see that 160 degrees doesn't have an acute angle. So what do? We use our reduction formulae. So how does our reduction formula look like? Here it is. So make sure that when you're solving your three equations, always have your reduction formulae in position. So the reduction formulae, we know that in the first quadrant, all the trig ratios are positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. In the fourth quadrant, only cos is positive. So also you must know the values that in the first quadrant is 90 degrees minus, in the second quadrant is 90 degrees plus, then also 180 degrees minus, then 180 degrees plus, then we also have 360 degrees minus and 360 degrees plus. Please, I left 270 intentionally. Why did I leave 270? Because if you try to use 270, you're gonna forget to use what we call the core ratios. So to prevent that mistake from happening, instead of you using 270, if that value, maybe you are given 245, you can see that it's in the third quadrant, use 180 degrees plus. If you have 330, don't use 270 plus 60, use 360 minus, so that you can use 360 and you can prevent yourself from having careless mistakes, since you now have to convert things and reciprocating things. So don't confuse your life, just enjoy your life as much as you can, because you don't need to have much stress. So collect marks as much as possible. So now we know how do we solve or how do we reduce this. We start by the angle. So our angle which we have here is 160 degrees. So since we have 160 degrees, 160 degrees is in which quadrant? It's in the second quadrant. And in the second quadrant, we know that it's 180 degrees minus, or you can say it's 90 degrees plus. But in this instance, let's use our 180 degrees minus. So it's going to be sine of 180 degrees minus what? Minus 20. Because 180 minus 20 is equal to 180 degrees. Why are we reducing? So that we can deal with acute angles. Okay. Then we have our cos of 40 degrees. Great. So now let's move forward. This is the same as negative 2 sine of 20 multiplied by sine of also 20, because sine of 180 minus 20 is in the second quadrant and sine is positive. Then after that we have minus cos of 40 degrees. Now moving forward from this instance of on this problem, now we know that sine times sine is sine squared, so it's going to be negative 2 sine squared of 20 degrees minus cos of 40 degrees. Okay, now what do we see about this 40? We know that we have what we call the double angle, sine squared of 20 degrees minus. So this is a double angle, which is cos of 2 times 20 degrees. Okay, so your mind must be able to work fast, in a sense that it can be able to think and tackle the content which you have been studying all along the way. It's now 2 sine squared of 20 degrees minus. So since we are dealing with sine, so you can actually write this in terms of sine, change this double angle in the terms of cos, so it's going to be 1 minus 2 sine squared of 20 degrees. Then this will be equal to negative 2 sine squared of 20 degrees plus 1 plus 2, it's negative 1 here, because now we are multiplying negative times 1 is negative 1, negative times negative is positive, 2 sine squared of 20 degrees. Then now we can see that this and this is 0, then your final answer will just be negative 1. Just like that, you get your marks, you are happy. Make sure that your happiness comes first. Don't do silly mistakes. Okay, now let's solve 5.3. Let's do and look at 5.3.1. So let's maximize our screen. Okay, great. So here we have it. We have 5.3.1 now. So they are saying consider 3 cos x times sine x plus 2 tan x multiplied by cos squared of 180 degrees minus x. Simplify the expression to a simple trigonometric ratio. So in other words, they are saying simplify what they have given you ahead. So they gave us, let me do this. Great. So they gave us 3 cos of x They gave us 3 cos of x multiplied by sine of x plus tan of x multiplied by cos squared of 180 degrees minus x. Okay, great. Now we must simplify to a single trigonometric ratio. Now let's go. This is interesting. Now, what is important is to analyze this thing. And how do you analyze and how do you simplify trigonometric expressions? You must look for what we call identities. So we have two identities. Tan x is equal to sine x over cos x. We also must look, do you have double angles? And the double angles is for sine and cos. So we have sine of 2 theta, which is equal to 2 sine theta multiplied by cos theta. Then we also have the double angles for cos, and they are unfortunately they are 3. So you can choose from variety. But the one I love the most and the one which you must always try to use first before you use other alternative is the one which says 2 cos squared of theta minus 1. Then the other one is cos squared of theta minus sine squared of theta. Then the last one is 1 minus 2 sine squared of theta. Don't worry about trying to cram those double angles. Know how to apply them, because on your formula sheet you'll be granted those double angles. So when you are solving trigonometric expression, always bear in mind that you must look at, if you are given an identity, convert that identity. If you are given a double angle, convert that double angle so that you can have your answer in a right manner, and now you can simplify it to a single trigonometric ratio. So now let's go. Let's deal with this. Great. So we have 3 cos of x multiplied by sine x plus tan x. We're going to convert this. Now let's look at this. Cos 180 minus x. 180 minus is in which quadrant? It's in the second quadrant. Is cos positive or negative? Cos is negative. So now we have negative cos of x. But bear in mind that it is squared. Now let's go. 3 cos x multiplied by sine x plus tan x. What do we know about tan x? Tan x is an identity. So you must convert that identity to, let me write it a different pen so that you can see this. So it's going to be sine of x. It's going to be sine of x over cos x multiplied by, now anything squared, even if it's a negative 1 squared, it's positive. Negative 100 squared is positive. Negative million squared is positive. Negative x squared is also positive. So also in this instance, our cos now is going to be now cos squared of x. I use the different pen so that you can actually see. Okay, great. So now we have our 3 cos of x multiplied by sine x plus, then cos x and cos x, they divide each other. So we have positive sine x multiplied by cos x. Why? We know that cos squared of x here, it is the same, this cos squared of x is the same as cos of x multiplied by cos of x. So this cos of x and one of these will cancel. Then we are only left with 1 cos of x n times sine of x. So we can actually see now that we are now having what we say common or like terms. So 3 cos of x, let's just rewrite it in the same way, multiplied by sine x plus cos of x multiplied by sine x. So it's like we are saying sine 3x plus x is the same as 4 cos of x times sine of x. Then you get all your 4 marks just for being able to do this. And after that, do you see that this can be written as 2 multiplied by 2 cos x sine x. Then we can actually see this is a double angle for sine. So you can actually now finalize the answer that you have sine 2x. You see? Then you get all your 4 marks. So what is important in simplifying into simple trigonometric ratio is to be able to see that you must reduce step by step, reduce all the identities step by step, reduce them so that you can have the correct answer. Okay? So the key, we say that we convert all identities, and we also solve, or we use the reduction formula so that we can have simple trigonometric ratios. Splendid. Now let's move now to the next problem. So 5.3.2. Now we're looking at 5.3.2. So on 5.3.2, hence write down the range of f of x equal to 3 cos x multiplied by that. So the moment they say hence, your mindset must tell you that, okay, the fact that they say hence, which means I must use what I've already calculated before so that I can achieve the answer for this problem. Okay, so don't worry yourself about that. The moment that you see hence, which means they say that f of x is equal to 3 cos of x times sine x plus tan of x multiplied by cos square of 180 degrees minus x. So now they say hence determine the range of this. So don't worry yourself. Hence underline that factor or that term, that English nice term which is written as hence. So that English nice term which is written as hence means that use what you have calculated previously in this instance so that you can get your final answer in a fast way. You can actually look even on the mark allocation. It's only 2 marks because you just have to use what you have done already above. So this will be our f of x is equal to 2 sine of 2x. Then, now, perfect. Now, when we are plotting the sine function, we know that we look at the amplitude and we also look at how we draw our function. So we know that the original function of sine is just like this. We know this. This is only for sine x. But now what is the range? It will be 1, 2 to 1. Looking at this is what we call the amplitude. So when we want to determine the range of the function, we want to look at the amplitude on how high and low your function can go. And we know that even when we are doing our calculus graphs or even parabolas, we know that in order for us to determine the range, we only look at the aspect of the y-axis. So we determine our range looking on the y-axis. So having that in mind, which means now this value is the one for the amplitude and is the one which is going to affect the length of the function. So our range in this instance now, we know that is written in terms of y. So it's y element from -2 to +2. Great. So that will be our range for the function y, because we are looking at this instance that f of x is equal to 2 sine of 2x. So that instant is what's bringing us to have this final conclusion that we have this as our range. Now 5.4. Steadily we are moving and we are passing. 5.4, prove the identity, which is given as cos of 3x over cos x is equal to 4 cos square of x minus 3. Great. Now we want to prove this identity. So how are we going to prove an identity? You can never prove both sides at the same time. Never ever you can do that. So you must pick one side first and deal with that side. Then if they are still not balancing, you're also going to choose another side. So now let's get down to the business. Now on this instance, let's look on the left hand side. So when you're going to focus on the left hand side, what do you do first? You start by writing left hand side is equal to cos 3x over cos of x. Why are we doing this? So that we can show the examiner that no, I know what I'm doing. Show and write this simple English, that left hand side, so that we can actually realize which side are you proving. Okay, so now we are proving this side. So now let's go. So how can we prove this thing? We can prove this thing, and what do we know about 3x? We know that 3x is the same as 2x plus x. So having that in mind, so it's going to be cos of 2x plus x, all divided by cos of x. Now, if now it's now in this sequence, or our cos is now written in this instant, so now we can now apply what we call the compound angles. So let's apply our compound angles. So our compound angles will be cos of 2x multiplied by cos of x minus sine of 2x times sine of x, all divided by cos of x. Okay, we are getting somewhere. This is interesting. Let's go. Cos 2x multiplied by cos of x divided by cos of x minus sine 2x multiplied by sine x all divided by cos of x. Wow. Why are we doing this? Because we know that when we were taught in grade 1 that 1/4 plus 1/2 is equal to, it is the same thing by breaking down. You start by looking the common factor, then you solve. So now we are reversing the process. So for instance, you're saying 1/4 plus 1/2. We know that now we must look for the common factor. So in this instance, the common factor will be 4, then it will be 1, then here we have our 2. So when we break down this common factor and bring it back to the original fractions which we had, that will lead us to also have 1/4 plus 2/4, which is actually the same as 1/4 plus 1/2. So we are using that same concept which we have, that we can use it in this instance, that okay, initially we had cos 2x multiplied by cos x minus sine 2x times sine of x, and they were all having the common factor, common denominator, which is cos of x. So now we can actually separate them and use the same notation so that we can actually have separate expressions. So let's do this first so that you can clear our working space. Here we go. Great. Now let's go. We can actually see that cos and cos will cancel each other. Then we are only left with cos 2x. Oh. Then cos and sine x. We can see that this is an identity. Which identity is this one? We know that this identity is the same as minus sine 2x multiplied by tan of x. Great. Now let's play around. Let's enjoy life. Let's start by attacking this other side before we determine our cos. Why am I saying that? Because we know that cos 2x can be actually simplified in 3 ways. This is a double angle which can be 2 cos squared minus 1. It can be 1 minus 2 sine squared of x. It can also be cos squared minus sine squared of x. So let's look at our other side. What are we going to get before we finally conclude? So now we have cos of 2x minus sine 2x. It's a double angle, which is the same as 2 sine of x multiplied by cos of x. Wow, this is amazing. What is tan x? Tan x is an identity. So our identity, which is sine of x over cos of x. Wow. So we can actually see that this cos and this cos will cancel each other. Then now we can proceed, and now we have our cos of 2x minus 2 sine square of x. So let's look. It is supposed to be equal to 4 cos squared minus 3. So there is nothing about sine here. There is only some things about cos. Okay, great. So now let's go. We know that cos 2x can be written in 3 expressions, and we only want cos as our final answer. So this can be 2 cos squared of x minus 1 minus 2. Then we know that sine squared of x is also an identity from the 2 identities which we have. And sine squared of x is the same as 1 minus cos squared of x. Wow. Unpacking this as much as we can. So now we have 2 cos squared of x minus 1 minus 2 plus 2 cos squared of x. Then 2 cos squared of x plus 2 cos squared of x is 4 cos squared of x. The negative 1 minus 2 is negative 3, which is equal to the right hand side. This makes me happy. You see, you don't do any mistakes. How did we solve it? Is being able to apply the concept or the basic overview which we gave you on one of our videos, that be able to solve common angles, be able to see identities, also be able to use the double angle. So trigonometry is only revolving around these 5 things, that they are identities, they are 2 identities, they are so crucial. They are also double angles, which are almost 6. They are also compound angles, they are graphs. Then this is the concept which you use to actually analyze and answer all the questions which you are given on trigonometry. So we were able to actually solve this nice and simple and great. So what we first did is to be able to see that we are given 3x. So 3x, we said, is the same as 2x plus x. So we just use that the same instant. Then after that we see that, oh, now we have a compound angles. Then after that we solve and we looked at our compound angles. Then we're able to actually prove the identity. Now let's look at 5.5. Let's look at 5.5. So determine the general solution of x in the following equation. This is great. It's my first time to see this kind of thing. But let's be excited. We have given 3 to the power 2 tan x minus 3 tan x plus 1 equal to 54. Okay, 54. Okay, great. We have 54. Okay, let's proceed. Equal to, we don't put an equal sign because it's a general solution. So now we can have 3 tan 3 to the power 2 tan x, okay, minus 3 tan x times 3 to the power 1 is equal to 54. Okay. That's something else. So we can solve in this. I want to give you two options in which you can solve this, okay? So 3 to tan x is the same as 3 to the power 2 times tan x like this. So if we take, let's see, 3 tan x as a common factor, so we'll be left with 3 to the 2. Let me see. Okay, let's solve it in this other way then. Then we transpose 54 to the other side. So it will be negative 54 equal to 0, because I tried to solve it like the way we solve exponents, but I saw that it's going to give us a bit of a problem. So in order for us to not have a problem, we find a simpler way we can solve this. So now let's solve this. So this is the same as what? This is the same as 3 to the power tan of x. Don't worry about many things. Minus 9. Okay? And also 3 to the power tan of x plus 6 equal to 0. Guys, do you see that this is actually a what's this? This is actually a quadratic equation. You must have this thing in your mind that, okay, let me just use my general knowledge. This is actually a quadratic equation. Why? 3 to the power 2. Let's just treat tan x as x. So this will be the same as 3 to the power 2x minus 3 to the power x times 3 to the power 1 minus 54 is equal to 0. Then after that, we apply our K method. So applying our K method will result in us having these two factors. Or you can just solve it directly as the way I'm doing that. We can actually see that, oh, okay, this is just the simple thing which is like an exponential function, exponential equation, which you can solve in the same way as well. So if you are here, you can actually see that, oh, okay, this is the same. So this can be treated as your K. So this now will be K squared minus K minus 54 is equal to 0. Someone ask, I'm hearing someone ask me, why are you saying that? Because we applied our K method. So when you're applying your K method, when we're solving for x, we say that applying K method will mean that we write this simple English which says that, come on, let K be equal to 3 to the x. So in this instance, 3 to the x will be equal to K. So since it's 3, so now it's K squared minus 3K minus 54 equal to 0. So after that, what do you have? Why are we saying this? So let me also write that, and x is equal to tan x, so that you can actually see what I'm saying and solving it in a breaking down point. So after this, you can actually, this is now a quadratic equation. Then it's going to be k minus minus 9 as well as k plus 3 is equal to, is it 3? It's 6, sorry. Yes, great. It's equal to 0. Then your first k will be equal to 9, or your k will be equal to 6. The negative 6. Then definitely, what was our k? Our k was 3 to the power x. So 3 to the power x is equal to 9, or 3 to the power x is equal to negative 6. This is no solution. Write that down, that no solution, so that we can actually see that you were able to see that there is no solution. There is actually a mark for that, for being able to conceptualize and say, okay, this is what I have, and there is definitely no solution on this. Write it down so that you can get an answer. I know when you try to use a calculator to write like maths error, that maths error, you cannot write maths error here, but just write no solution so that you can be awarded your mark for just seeing that you are able to realize that. Then what was our now we can solve this. 3x is equal to 3 to the power 2, because 9 is the same as 3 to the power 2. Then our x is now equal to 2. What was our x initially? Our x was tan of x. So tan of x is equal to 2. Then x is equal to tan inverse of 2. Then what is your angle when you use 2? Then you can get that your angle, you use your calculator now, then your angle will be 63,43 degrees. So this will be x. But we are determining the general solution of x. So what do we know about general solution, which include tan of x? We know that where there is tan of x, which means therefore it's going to be x is equal to the period of a tan function is only 180 degrees. So therefore you can actually see that the calculated angle, which is 63,43 degrees plus 180 degrees of k, okay, or you can say that k of this, where k is the element of real of integers. Just like that, then you have your answer correct. So let me recap again. So I tried to use this shorter method, but I figured that, okay, I'll be sort of like not giving you the full detail. So this, when you break it down and treat tan x as x, you can actually see that this is an exponential equation. So when you know how to solve exponents, this is how we solve exponents. So we break them down. So we have 3 to the power 2x minus 3x times 3 to the power 1 minus 54 equal to 0. Then after that, we applied our K method. If you want to make sure that you're solving for X skills, your algebra skills are more polished, please do check on the video of Solve for X, which we have also, which we did last term. It's also there on our Yebo Tutor channel. They will teach you more about K method. So this is the K method which we use so that you can actually be able to solve the exponential equations. Then after that, you're able to find that our K values are 2, we have 9, and it's also negative 6. Then now, what was K initially? K was equal to 3 to the power x. So now we solve it. Then after that, we have our answer, and we have our x will be equal to 2. What was x? We said x initially is equal to tan of x. Then after that, you live happily after. Now we are doing the last question of the day. We're doing the last question of the day, which is graphs. We're doing the last question of the day, which is graphs. Now, this is the graph which you are given, question 6. So on the graphs which you are given, we're given that in the diagram, the graphs of f of x is equal to negative cos of x plus 1 and g of x is equal to 2 sine of x plus 30 degrees are drawn for the interval x element of negative 180 degrees to positive 90 degrees. That's the interval. Actually, that's the domain of the function. So if they ask you about the domain of the graph, automatically you know that, okay, this graph is between negative 180 to 90 degrees. Just like that, even if they didn't tell you, if they ask you for the domain of the function, what's the domain of the function? The domain of the function is x element of negative 180 to 90 degrees. Why? Because the interval and the domain, they are the same thing, in the sense that the x values of your graph are always the ones for the domain. That's what you use to determine the domain of the function. For which values of x in the interval of x element negative 180 to 90 degrees will f of x multiplied by g of x be greater or equal to 0? This is great. So now on question number 6, so we want, it's 6.1.1. So in this question, they are saying that for which values of x in this interval will f of x multiplied by g of x be greater or equal to 0? So in other words, where are these two functions positive? Bear in mind that when you say positive 1 times positive 1, you get a number which is greater or equal to 0. But when your values now are negative and positive, which means that it won't be greater than 0. And also when they are both negative, they're gonna give you a value which is greater than 0. So we're just using that same conceptualizing mindset. Okay, great. So let's look at our function. Where are the both graphs too high? You can see the f here from negative 180 to 0. We can see that other one is positive, other one is negative, which means that part is out. Just like that, let's look at negative 30. Do you see that on negative 30? They are both above the x-axis. They are both positive. So in that interval, these functions, when they multiply each other, they will be greater or equal to 0. So we can see that from x element from negative 30 degrees to positive 90 degrees, these graphs, they are greater or equal to 0. Then 6.1.2. Now, what are the values of x for which g of x is equal to negative 1? Where is g of x? G of x. This is g of x. So where is this function equal to negative 1? So I always love to say that it's equal to negative 1, negative 1. You can see negative 1. So I want to tell you this trick, guys. Okay. So you're given this 2 sine of x, you can just say it is equal to 1. So g of x will be equal to 1 in that instant. Then after that, you solve for the values of x, but it's going to take time. Or you can actually analyze your function. You can actually see that they're equal to a negative 1 when x is equal to negative 180 degrees. Look at that, negative 180 degrees. And also when 60, x is equal to negative 60 degrees. Do you see that? That's where the function of g of x is equal to negative 1. So it's about applying and just looking at your graph. 6.2 now. 6.2, 6.2, 6.2. The y-axis is shifted 90 degrees to the right. Determine the new equation of the graph originally called f in its simplest form. Where is the graph of f? So it has been shifted on the y-axis. So in other words, initially we were having the function of f of x equal to negative cos of x plus 1. Then the new function, which will be, let's just call it fh of x, which is the new function, will be negative cos of x. It has been shifted 90 units to the y, along the y-axis. So it's going to be x plus 90 degrees plus 1. Then now we have our negative cos of x plus 90 degrees plus 1. So we know that this is the same as negative cos of 90 degrees plus x plus 1. And cos 90 plus is a co-ratio of sine, and cos is in the second quadrant, and cos is negative. So negative times negative is going to give us a positive ratio, which is negative sine x plus 1. So this will be the new function. Why did we simplify it? Because they told us to do so. They say that in simplest form. So that is that. So today we're doing trigonometry. It was a nice session which I had with you guys. Please, if you have more questions, do check us out on our WhatsApp group. Then we'll be able to assist you as much as we can. Without further ado, have a blessed day and enjoy your day. Do look at the video and share with friends and family, and have tune in on our next session which we have. Bye.